Hello students, we are here now to introduce you to the theory of limits, continuity and differentiability. Actually this is a very important chapter for JEE Advanced because this topic especially is used in many other places, many other topics. So yeah, let's start the theory of limits, continuity and differentiability.
Exactly. It's not equally important, but the thing is that it's very scoreable chapter also. So we must have our eyes set on this chapter because it will help us score a very good amount of marks. So moving ahead with the theory, we'll first take up the topic limits. So what is exactly limits? What we exactly do in limits? So like you can see, there's a curve over in the there's a curve that can be seen in the screen. It points at x equals to a. So when x tends to a plus delta, we call that as the right neighborhood, and fx tends to a function of a plus delta. Similarly, when x tends to a minus delta, fx tends to f of a minus delta. This is called as the left neighborhood. Okay, so now moving ahead to the next step, let me introduce you to the 7 indeterminate forms that exist. They are respectively 0 by 0, 0 into infinity, infinity by infinity, infinity minus infinity, 1 raised to infinity, 0 raised to 0, and infinity raised to 0. So basically, whenever we are supposed to be finding out limit of a given question, they will be reducing to one of these above 7 forms. So what is the definition of limit says that definition of limit says that when x tends to a, fx equals to fx plus a. So if limit exists, this limit fx plus a should be a finite number when x tends to a. So briefing on for the existence of limit, we'll say that limit exists if and only if left hand limit will be equals to the right hand limit. That is limit function of x when x tends to a minus delta equals to limit function of x when x tends to a plus delta. Moving ahead, I'd like you guys to introduce to the theorems on limits, which will help you a lot in solving the questions. So first we'll take a consideration that limit fx and limit gx exist at x tends to a. So the first theorem is limit x tends to a, k times fx equals to k times limit x tends to a fx. Here k is a constant value, so we can take it out of the bracket. Continuing with the theory, we have considered that limit fx and limit gx when x tends to a exist and is equals to a finite value. So the second theorem over here is that when limit x tends to a, fx plus minus gx equals to limit x tends to a, fx plus limit x tends to a, gx. This can be universally taken in solving questions. The third point is that limit x tends to a function of x into g of x equals to limit x tends to a fx multiplied by limit x tends to a gx. The fourth theorem states that limit x tends to a fx divided by gx equals to limit x tends to a fx divided by limit x tends to a gx. But we should keep in mind that limit x tends to a g of x should not be equals to 0. Similarly, moving to the fifth theorem, limit x tends to a function of gx equals to function of limit x tends to a gx. This is the way we apply limit and composite function. So but one thing that requires for the existence of this is that limit x tends to a g of x equals to k, which is a finite value, and limit x tends to a fx exists at x equals to k. And the sixth theorem states that limit fx raised to gx x tends to a equals to limit fx raised to limit gx x tends to a. And the seventh one states that limit x tends to plus infinity fx equals to limit x tends to plus 0 function of 1 by x. The eighth one states that limit x tends to minus infinity fx equals to limit x tends to 0 minus 0 function of 1 by x. The ninth and one of the most important theorem states that it's a sandwich theorem. It states that if gx is less than or equals to hx, which is less than or equals to fx, and if at x tends to a, limit of gx equals to limit of fx, it implies that limit of hx equals to the equals to k, which was equals to the limit of the other two functions at x equals to a. Some standard limit that you must remember is that limit sin x by x equals to limit x by sin x equals to limit sin inverse x by x equals to limit x by sin inverse x when x tends to 0 and these value becomes equals to 1. The second one is that limit x tends to 0 cos x equals to limit x tends to 0 1 by cos x equals to 1. The third one states that limit x tends to 0 tan x by x equals to limit x tends to 0 x by tan x equals to limit x tends to 0 tan inverse x by x equals to limit x tends to 0 x by tan inverse x equals to 1. The fourth one states that limit x tends to 0 1 plus 1 raised to 1 by x raised to whole raised to x equals to limit x tends to 0 1 plus x whole raised to 1 by x equals to e. The fifth result is that limit x tends to a function of x if it tends to 1 and limit x tends to a gx if it tends to infinity, then limit fx raised to gx when x tends to a equals to e raised to limit x tends to a fx minus 1 in whole multiplied by gx.
So your students, the most important thing which you need to remember is that the formulas which he just mentioned are very important. These are the formulas and these are the theory which you will be using all along the chapter in every part during solving the questions.
Here are some other results that you should remember. Sixth one is tan x, seventh is tan inverse x. Similarly, you can take use of 8th and 9th expression for simplification of the question. Here are some mentioned standard methods to solve limits questions, which are rationalization, factorization, substitution, binomial approximation, L'Hospital and sandwich theorem. Now let us start the theory portion of the continuity. Continuity: a function is said to be continuous when limit x tends to a minus fx equals to limit x tends to a plus fx equals to function of a. Here are some notes that you can refer about a continuous, what are the properties of a continuous functions and what is the requirement for a function to be continuous. Similarly, there are some miscellaneous properties that has been given over here. The cases when fx and gx are continuous or discontinuous, so what happens to the fx plus minus gx, fx gx and fx divided by gx. So you can just scroll down and refer to them. Moving to the next layer, we see that there are certain types of discontinuities. So the main two types of discontinuities are removable discontinuity and irremovable discontinuity. In removable discontinuity, it's basically of two types: missing point discontinuity and isolated point discontinuity. Whereas in irremovable discontinuity, it's basically of three types, which is finite discontinuity, infinite discontinuity and oscillatory discontinuity. Now comes the continuity of composite function. F of g of x is a composite function and it is continuous at x equals to a if limit x tends to a gx exists and is finite, and fx is continuous at limit x tends to a g of x. Similarly, a very important theorem is intermediate value theorem. Intermediate value theorem states that if fx is continuous in a to b and if function of a and function of b possesses opposite sign, then there exists at least one solution of the equation function of x equals to 0 in a to b. Similarly, if k is a real number between function of a and function of b, there exists at least one solution of function of x equals to k in a to b. We can clearly understand this with the help of the graph that has been shown in the figure.
Now friends, let's go on with the theory of differentiability.
Differentiability. A function is said to be differentiable at x equals to a if and only if f dash a plus equals to f dash a minus and should be a finite value. Okay, so we can find out f dash a plus and f dash a minus with the help of first principle. Now moving ahead with the concept of tangent. Tangent exists if f dash a plus equals to f dash a minus, and this is equals to the slope of the tangent. A very interesting one is a vertical tangent concept. For a function to possess a vertical tangent, it need not be a continuous function, as we can see in the graph of signum x. Similarly, a function to be differentiable at x equals to a, it is necessary that it should possess a unique non-vertical tangent at x equals to a. So moving into the next slide, we can see that there is certain relationships between continuity and differentiability. Looking into the three graphs, we can see that continuity does not imply differentiability, but differentiability implies continuity. Similarly, moving ahead, for the rules of differentiability for in the interval a to b, we must check that f dash a plus and f dash b minus exist in finite, and f dash c minus equals to f dash c plus for c belonging to a to b. Now here are certain notes and given for the differentiability of the function, which you can go through. Now a lot of questions comes like when you're given the function rule and you have to find the solution for that. So in these type of questions you can follow some preliminary basic steps, which is first is finding out f dash x using first principle, second is manipulating the numerator, and the third one is integrating and applying the conditions that has been given to us. So friends, this is the theory portion of limits, continuity and differentiability.
So yeah, students, now we have given you a brief overview of the theory of limits, continuity and differentiability. It's very important to remember the formulas of all the chapters. In a similar way, the formulas of limits, continuity and differentiability play a very key role in solving the questions, which we'll show you how to use those formulas in the questions coming next. Anyways, let's move on to questions now.